Yeah. So thank you for having me here. Thanks to the organizers, especially Ram Shri Ram, Sub, and Ken, who contacted me to be a speaker at this summit. And it's, of course, a pleasure to be interacting with you this morning. It's a little late evening for me. And I would like to introduce a particular kind of knowledge organization based in library organizations. And this is known as the faceted approach to knowledge organization. Before I start off, a little bit background about myself and my institution where I work. It's called the InflibNet, Information Library Network of India. I am the director here, and this was established in 1991 and became a part of UGC, the University Grants Commission, in 1996. And we offer, by mandate, we have a mandate of networking the academic and scientific libraries of India through digital information, knowledge and information infrastructure. And as we speak, we have 10 verticals, like in the area of library automation, access to scholarly resources, open access initiatives, and various others. So we have a pan-India presence networking the libraries. And our key projects are, one of the key project is having the world's largest full text thesis, electronic thesis online, and we have nearly 600,000 online. So like this, we have several programs which are quite impactful and serving across our country. And one of our latest offerings is the One Nation, One Subscription. Yes, India as a whole has One Nation, One Subscription to scholarly publications of 30 renowned international publishers. And this we are proud of because India is a large country. It's a diverse, very diverse kind of institutes, but we could all bring them all under one subscription. And many countries are now asking us about how we pulled this off and how we could help them. So I thought, in short, I will just introduce about me and my background. Thank you for your patience. And now I'll come to the crux of the matter, what Ken was explaining a few minutes ago about how knowledge structures and knowledge organization is done. And I, in a very great enthusiasm, agreed to be a speaker at this summit. And then after agreeing, I started wondering whether this is mathematical modeling or modeling mathematics as a domain. And I'm very, very glad that I heard Ken now that it is about modeling mathematics. And for most part, my examples here would be from agriculture and food, because I worked quite a bit with those communities. But I have also done a bit of modeling for mathematics in the towards the end of my talk, so that it makes some sense. And yeah, I could fully understand if you would label this also as abstract nonsense at the moment, because this is a take from the library based organization rather, but it's equally applicable again across other domains. It is amenable to computer modeling also, which we have tried, which I'll talk through this my talk. Ken, I have a question. Should I finish my whole talk and then anybody can ask questions, or are they allowed to stop me as they have questions?
Um, if they raise their hand, I can
Yes, we
let
feel
them ask a
free.
question. Just have them raise. Just people should raise their hands.
Okay. Feel free to stop me wherever you feel like, because the terminology, the concepts are, like I said, from a different angle. We are talking about organizing library collections and knowledge resources and using facetization as a technique. So if there are questions, I'm very happy to take them. Right? Okay. Now, there is what is called as the principled approach to classification, and faceted classification is one type of classification. It was introduced by Professor S.R. Ranganathan, who is deemed as the father of library sciences in India. Now, what exactly is this facet? It has been used in different connotation. Facet is synonymous with many times categories. Nowadays, people call filters. It could be attributes, class, group, concept. So it has been used interchangeably. But in classification we use it very formally in the library classification. So classification itself is again used synonymously in different contexts, but in library science it is an exercise for of the powers of perception and reason, which enable assembling things in an order of likeness and separate them according to an order of unlikeness. That means we are trying to create orders. Like, you imagine you are going to walk into a physical library, you're going to go and stand in front of a shelf. Say if you are mathematicians, you're going to go and see the collection on mathematics. You would like to see everything organized according to a logical order, however you know that subject, however you relate to that subject. So the classification's purpose is exactly that, to bring upon an order of likeness and remove the unlikeness so that there is all likeness together. This is the chief objective of classification. Hence, it is not merely grouping as people would like to describe it. It is the arrangement according to principles. So it is Ranganathan who first of all followed a principled approach to classification, which was not done before him. So Ranganathan put forth his faceted classification theory as early as 1930s, and it is a category. A facet is a category that expresses a particular aspect of knowledge being described. And also, a facet in itself is a hierarchy of homogeneous terms, where each term in the hierarchy denotes an atomic concept. Okay, so on the right hand side of my slide, you can see some examples. So if you take the domain of knowledge and you divide it by a characteristic, like we divide languages by Indo-European language, then you get such an hierarchy. You divide it by Dravidian languages, you get that hierarchy. Or you divide languages by geographical location, then you get Japanese, Indian, African, and such hierarchies. So what is faceted analysis and classification? As I said, facet is a distinct division of a domain. Facet is a set of classes which are got by applying characteristics successively. And many facets, such facets together make up a domain. So different domains have different combination of facets, and hence they are unique in how they are. And based on facetization, we long after Ranganathan is gone, we applied his theory to ontologies, and we arrived at lightweight ontologies called faceted ontologies. Faceted ontologies create consistent and cohesive knowledge structures for data modeling and representations. But again, as I said, this depends. This is based upon faceted subject and analysis itself, which allows classifying an object from multiple perspectives. Okay, predefined patterns which capture different aspects of the meaning. They express the degree, they have a degree of expressivity and granularity. Like, if you want at a generic level, you can express at a generic level, but if you have a concept at much deeper in the hierarchy at a specificity level, even that can be represented. Okay. So what was this faceted theory by Ranganathan? So Ranganathan has three planes of work, which again I will be explaining in detail. The very first plane is called the idea plane, where we organize our ideas regarding a particular domain, which we are going to formalize. Okay. So idea plane, he gives the canons, or these are the directives or principles that he lays down. So the idea plane canons help in conceptualization to formalize and to analyze and formalize a domain. Facet, again, as I said, it's a generic term used to denote any component of the subject, be it a basic subject or a compound subject, which has one or more kind of concepts coming together. Now, what is a characteristic? A characteristic is an attribute which is used basically as the basis of classification. That is called a characteristic in simple words. And then by applying the characteristic successively, we get a class. A class is a ranked group. Okay. If a set of things is divided into groups based on characteristics or attributes, and those groups are ranked, then each such ranked group is a class. So this is where we start formalizing the hierarchy. We can't take, I mean, it cannot be random. We know in the hierarchical structure, which is rank number one, isolate, which is rank number two. So we have the characteristics itself organized in such a way that it yields the formal hierarchy. And an array is the class derived from a universe on basis of a single characteristic at any one step in progression. And these are arranged in a preferred sequence. And such a facet analysis itself is an intellectual process which leads to analyzing a subject or a domain into its facets. And this is based upon a book called Prolegmena to Library Classification, written by S.R. Ranganathan. And this book contains all the principles and postulates which have to be applied in a sequence that he prescribes to do facet analysis, so that we get the entire classification of whichever domain that we set forth to classify. So the facet analysis results in sorting of terms in a given domain into homogeneous, mutually exclusive facets, each derived from a common parent universe, or what he called it as common immediate universe, by a single characteristic of division at each level of hierarchy. So at each level of hierarchy, like I showed the language domain, if we use the characteristic by geographic location, then you get India, this. Within India, you use another characteristic, Dravidian and non-Dravidian languages, then you get a hierarchy under that accordingly. This is how we progressively build hierarchies. Okay. So basically, what it means is that the knowledge is not unidimensional. Knowledge is something which is multidimensional. So to very simply express it, you can take the edges of a cube like this, and this is how the topic is along one axis, and it is placed in the context of time and space. So this is what Ranganathan tried to do, that a multi-dimensional the feature of knowledge is there on one hand, and on the other hand he had the task of arranging books which contain such knowledge along one dimension, which is basically the shelf of a library. So he had to arrange knowledge along one dimension, but still not lose the logical progression of that subject. So this is what is the challenge about how we retain the dimensions of knowledge when we map them into something else. Okay. So just a random example, suppose we have a subject which says stormy weather during rainy season in Java Island or something like this. So how do we go along those three axes that I just showed? You take the topic. The topic we are talking about here is weather. We are talking about a space, Java Island, and we are talking about season by, we are talking about time by seasons. This is not time by period. Time by period would be whatever, AD, BC, or the century or the year. But here we are talking time by season. That is the kind of characteristic we are using. And space by land, continent, island, then come to Java. And then we use a land form, which is continent, ridge, mountain, rivers, everything, and then island is one kind of a form. So this is how we build classificatory hierarchy using the faceted approach. Okay. So Ranganathan, and also I was delighted to hear when Ken spoke that I heard there are a group of mathematicians who tried to model the domain of mathematics. Then I heard something about philosophers taking from philosophical foundations how knowledge is understood, knowledge structures are understood, and then libraries. How we formalize knowledge within libraries. Now, Ranganathan was a combination of all these three, actually. he borrowed deeply from the Hindu philosophical foundation, which Ram has very explicitly explained in his presentation. I went through his presentation. Thanks for sharing that with me. And Ranganathan had deep rooted thinking in that, and then he applies that Panchabhuta formula to uh, uh, domain modeling, which he used in his faceted classification. So these five fundamental categories which he proposed are nothing but Panchamahabhutas, which are the five fundamental way of looking at the universe in philosophy, rooted in philosophy. So he says that these fundamental categories are the basic building blocks, and they can be used to build complex subjects, just like you have the Lego. They call Legos as Meccano in his time, Meccano sets. And just like that, if you're given, a child is given a Lego set, it can go and make many shapes, whichever day, whatever takes the fancy, it can make that shape. So that is how the subjects are. They are not, the domains are. First of all, they are all different, they are diverse. And second, they are very dynamic. A domain doesn't remain the same ever. The new concepts are added, some concepts become absolute, some concepts gradually change their meaning and evolve. So domains are very, very dynamic. And when you say that we will model something like that, then we need a model that is also almost, I can say, biological in its growth and flexibility. And that is what Ranganathan achieved by having a model also, but by having postulates and principles to guide the work in modeling, so that it will have a almost a biological kind of a growth and adaptability to knowledge. This is his, in my view, the greatest thing that the greatest takeaway from what he did. Okay. So Ranganathan gave five fundamental categories: personality, matter, energy, space, and time. And then other professors at the Documentation Research and Training Center, where I also worked for 30 years now, uh, uh, they they followed his pattern, but made other models. And Bhattacharya was one professor who modeled it as domain, entity, property, action, and modifiers. This DEPA, it is called DEPA, and this was proposed in the early 80s, actually, early 80s. Okay. So Ranganathan divided the work involved in classification into three planes. The first plane is called idea plane. So idea plane is the plane or the stage where the domain and its manifestation is simply perceived or understood. We do not put pen to paper here, or we don't start using the computer. We just conceptualize the domain that we are about to classify. And for this also, though we are just in the thinking mode, but for this also, Ranganathan has a set of canons and postulates that guide the idea plane, the ideas that we develop about a domain. And I'll come to it in a while. And the second plane of work is the verbal plane, which deals with putting the actual terminology or the language to those conceptualizations that we form in the idea plane. And like I said, Ranganathan's task was to arrange library collection, physical book collections along the shelf of a library, and make it sensible to the subject experts who come in search of those books. So he had to use mapped notation, or classificatory language, if you please, or coding, for example, and use that to arrange the books along the shelf of a library. And that's why his third plane is notational plane. And in the ontology world, we really don't bother about this plane of work. Now, to just give an idea of one of the domains, you take medicine, how he did. So going by Bhattacharya's entity, property, action, and modifiers. So when we take medicine, what is entity, or Ranganathan's P, personality? It is body and its organs, the digestive system, circulatory system, so on and so forth. What is the property? Why? we are talking about the domain medicine. So medicine means there is something happening to the property, which is the body and its organs, and that something happening needs medicine. So the property of the body is it has disease. And the disease hierarchy is various kinds of disease, virus, bacterial, that, this, all, it forms a hierarchy by itself. And then we have the action. What is the action in the domain medicine? The actions are like nursing, like surgery, like diagnosis. All these form part of action, and it forms a hierarchy on its own. Now, all these three are not standalone, they may have modifiers. Okay, so we say there is a viral disease, the viral disease is infectious, so that is a modifier on viral. Or there is a fever, what kind of fever is it? It's a bacterial fever, then bacterial forms the modifier. It's a viral fever, then that forms the modifier, like that. And now, as we know, like there is a pandemic, and we say the pandemic broke out in Asia, then the space factor comes into picture. The pandemic broke out in 2020, if we say, then the time factor comes into picture. So this is how facets are modeled. Okay, before we resolve something like treating a COVID patient in India during the pandemic, suppose that is a title that comes in, and I try to fit that book into its logical sequence on the shelf of a library, then I need this kind of a representation to help me arrive at the right sequence, and then the right notation to place that book in its rightful place in the library collection. So this is the significance of faceted classification and how it works. Any questions so far, please? Okay, I'll proceed. So basically, the methodology is what Ranganathan called as analytico-synthetic approach. Okay, so it has part analysis and part synthesis approach. Okay, so the domain is analyzed. Okay, the relevant terms are identified, which are called as isolate idea. The isolate ideas expressed by the terms are identified and arranged into what we call facets, and some people very popularly call it as taxonomies. And but it is very much different from the flat taxonomies, because these are arranged according to principles on which we base principles used for the division of the domain, which are known as characteristics. The set of taxonomies together form the faceted classification. So let's take some examples and see why we need it. Okay. Now, you ask some mundane questions like, I want to know the homepage of Tim Berners-Lee, or you want to know how many persons, uh, who are the persons with whom he has written papers. Suppose some mundane questions are asked like this. So how does a system try to answer such a question? So there must be somewhere a discourse that semantic web was started by Tim Berners-Lee. He was also some web page about him is given, and then his papers are given. These are his papers which he has published. And then we notice that one such paper was published by, say, or in collaboration with Jim Handler and Ora De Sila. Suppose this kind of a discourse is somewhere out there, then we say, pose the question, what is the URL of his web page, and who are the co-authors that wrote with Tim Berners-Lee. So it is pretty, I can say, straightforward to sort of model this. We need to model it to answer that question. And it is pretty straightforward. We will have probably such a representation, and we say that a person has a co-author that has a cardinality of two persons collaborating, and such kind of representation we build, which is quite straightforward, and through which we can answer the questions, who are the co-authors of Tim Berners-Lee. It is pretty straightforward and easy, because we have a one-to-one kind of a relation there already represented. Now take a topic like, what are the documents on effect of nitrogen fertilizers on rice plant, right? Is this as simple as answering who are the co-authors of Tim Berners-Lee? No, because here it is all subject based, or what we call it as the domain based terminology or concepts that we are trying to retrieve. There are many types of fertilizers, out of which we want only nitrogen-based ones here to answer this question. What is the effect on a part of a plant or the rice plant? What is the variety of the rice plant we are talking about? What is the effect of nitrogen fertilizers on which part of the plant? And different types of manuring. I mean, there's so many more angles that come out of this single question, that what are the documents available on effect of nitrogen fertilizers on rice plant? Okay. So it takes a lot of modeling. So we have to model the domain agriculture itself. And here is where Ranganathan gives. Well, modeling, how do you do? You do it systematically. Like we trace the disease, treatment of diseases in a mango plant. Suppose I take that. That is a specific subject that I'm looking at. But that is a sub-subject within agriculture. And how we can trace it is parts of a plant, which are the kinds of plants, what are the manuring, harvesting, whatever that action hierarchy. And then we have a hierarchy where fertilizers treatment and all these things manifest. So this is how, if we model a domain, we can answer the question. So according to Ranganathan, this is called as thought content of a document. That means what is the actual thought. It is not the pages of a document. He says knowledge of a document. What is the knowledge within a document? And then he says how we need to do is to have contextual retrieval. For contextual retrieval, we need to have a contextual representation. Okay. For example, if we say virus, just use the term virus, there are at least two contexts that can occur. The virus can be agricultural or plant-based, like I've shown an example over here. The virus could be the virus affecting human body, and it is part of medicine. So this domain is medicine, the other one is agriculture as a thing. So this is where we come across the thing. Non-faceted approach, we know that they take the flat metadata approach, and they think that we can answer something that is semantic in nature. But how can we really answer complex topics like the one which I just showed above? So this is where the facets help. Facets, as I said, are the constituent part of the discipline. So for agriculture, if I see sorry, I'm giving the examples by agriculture because I worked for quite some time with UNFAO and the colleagues there, and I'm also the founder member of the agricultural data group within the Research Data Alliance. So I have these always been working with that group. So the examples are from agriculture, but I'll show at least one example from mathematics, if that makes more sense later. So by agriculture, we have the facets like this: by parts of the plant, by processes, and by property of an action. So when we do the domain modeling, this is what happens according to Ranganathan. We model into entities, action, properties, which we call elementary categories, and those together form the discipline of agriculture. And this is the structure given. And now we create what is called as the aboutness of the document. So take a document. This is report on production of rice using nitrogen-based fertilizer. Suppose something like that. When I express the title in the expressive way, we say that in agriculture, rice product, because we talk about rice production, it is understood that this is a topic under the discipline of agriculture, and we use that. Then we do the concept identification, agriculture, then plant. Under plant, it is rice I am talking about. We are talking about production. We are talking about manuring, manures, fertilizers, and a particular type of fertilizers, that is nitrogen fertilizers. And then we create a representation or a hierarchy like this. So for a facet group of agriculture as a discipline, we'll have entities, plant, and different types of plants. Here we take rice plant, and then we take action, and the action words are production, manuring, and whatever that is. And we create a hierarchical map like that, which we call it as aboutness of a document. Now, against that comes a query. What are the effects of manure on rice plant? Some random query comes. So here it is the plant is the entity, rice, type of the entity, manuring is an action, manures are the entity of the action, and then effect, the modifier action on entity. What is the effect of that? And then we create the query analysis like this in a map. The query itself is analyzed. So we then can answer the query very well, because at the end, at the back end, we have a representation of the document which we created, and we match the query, and hence we achieve the match, and we can give a retrieval. Because in library mainly we focus on how efficiently we can retrieve information for our clientele. So that is how basically I would like to demonstrate the faceted system for agriculture. Now we extended that under an European Commission project which we worked with called Living Knowledge Project, and developed further extended the model so that we can have machine readable, machine processable way of facetization, which we call as faceted lightweight ontologies. Using that, we created we modeled the food domain. Okay, so how did we do it? So let us take one scenario, which is our motivational scenario, where people visit a restaurant, they order food, the food is served, and they eat food. So that is the simple scenario that we take. There are various questions that arise. Something like, what is the dish of the day? Uh, can you please remove the roasted pepper out of the pizza? Some all these questions. Find out the restaurant can serve a fasting cake, whatever that is, and so many such questions related to food and the restaurant scenario. Okay. Now, how do we really answer these kind of questions that raise? Okay. So that's why we modeled the domain food. Okay, and went by definitions, and we defined each of the entities there, and then model. So food is an edible natural object, or a processed food product which is made as a dish. Okay, and in this domain, while modeling, we came up with 7 core E types, we call them: people, recipe, menu, event, and the menu, event, a dish, and the person. So this kind of map we created, and with the relations along the edges, and we identify the various attributes, okay, of the food, whether something like whether the dish is a special dish, like on Christmas you have a special dish served which is only related to Christmas, for example, and something like that. Okay. So we derive all the attributes that are there according to an event, a festive event, or whatever that is, according to cooking method, according to ingredients, various things. And then we took what we call as the DERA approach. So this is the domain entity relation attribute approach. Basically, we derived this from the based in PMEST of Ranganathan and DEPA of Bhattacharya, DEPA of Bhattacharya. We arrived at the DERA within the Living Knowledge Project. And this we could use for representing various domains, including food. So I just give an example of food. Okay. So this is what is the summarization, that Ranganathan's PMEST is nothing but the P is a personality which forms the core focal identity, and it answers the questions who, what. Matter is the material, substances, properties, or attributes usually the tools, technology, resources, or they may be inherent characteristics also. Energy is actions, processes, operations, and activities. For example, methods, functions, and these things. And space and time, geographical and spatial objects, and temporal aspects. So, in the personality is the core of that and more specific concept, and it is in the context of DEPA and DERA, it is called entity, and these represent the main focus of whichever domain we are talking about. I was writing this for innovation, so that's why I've written this. Personality is sometimes implicit, like crops or farmers may not be explicitly stated which crops grow in sandy soil. If they ask, then crop is clearly asked. What grows well in sandy soil? If they ask, uh, we know that it is crop, though it is not mentioned explicitly. Okay, so some examples of personality are like crops, livestock, farmers, agro enterprises, and such. So matter is the material, substance, properties, resources, characteristics, and like I said, they may be intrinsic also. And for example, fertilizer application. Uh, so fertilizer is the matter, and application is the energy. That is the action actually. So matter examples can be many, like soil types, fertilizers, pesticides, nutrients, climate variables. Many such things form the matter. Energy is nothing but actions, processes, actions, operations, and the it is the most dominant or evident, I can tell, in I used for agro innovation as a domain. Okay, so when we take the examples, they may be examples like irrigation techniques, it could be precision agriculture, harvesting methods, and such things. Okay, some more examples, and space and time, of course, as I told you. So that is about the uh, basic classification that I talked about. Now, one thing I would like to draw your one more thing before I close. Am I up to the time? I think. Um, is Ranganathan's concept of facet formula. For each subject, he gives a string how he identifies the PMEST and in what sequence they should be given. Like if I take library science as a science, he says there are two levels of personality, 2P, and then ME and 2P. This is the kind of a sequencing he allows. So when we do according to him type of libraries, type school library, university library, like that goes, M will become the type of material within those libraries. And 2P, the E and 2P would be what kind of selection processes, what is the circulation within that library, like that. Now you take L medicine, he says L medicine has to be, L is for medicine, he says, has to be arranged, organized according to L, P, E, and 2P. So he actually models each subject in its own peculiar way, because he recognizes that not all subjects and their structures are equal. Each subject is unique, and its structure is unique. So we have to first understand that structure before we start modeling the subject itself. So for mathematics, oh my God, I'm very sorry, everything is jumbled because I use Open Libre, and I see that it has quite successfully jumbled up everything. But anyhow, for mathematics, he doesn't use like, for example, what I showed for law. Law, he uses Z is law, Z is law, and then P1, P2, P3, and P4 levels of personality isolates, he says. So he does that. For history, he has taken history is denoted by V, and then P2, E, and 2P, he has prescribed the formula like that. But for mathematics, what he does is he doesn't do at one go. He says B1 is, I think, trigonometry. I'm sorry, this is overlapping. Okay. Then he divides it into, first of all, arithmetic, algebra, analysis, trigonometry, various things. Why does he do it? Because mathematics is not like a subject like medicine or law that he has shown before this. those could directly be divided into personality, matter, action, like that. Mathematics is understood by mathematicians in canonical classes. The canonical classes are like arithmetic, algebra, trigonometry, etc. So he takes each component and then does the facet formula for each part of it, because each part may be peculiar or unique in itself. And then he has
Devika,
given
we
the.
only have one more minute
Yeah, I'm going to
for
conclude now. I
questions.
thought I'd just show a bit of mathematics before I can. Oh my God, my slides are all completely nicely jumbled. But in this slide, I tried to show a knowledge graph for the modeled mathematics, but it is jumbled. I'll share with you later in a PDF so that it looks much better than this. So we can sort of derive the knowledge graph out of the formalized structure for mathematics as a domain that I wanted to show. So that is the end of my talk. Thanks very much for your patience. And I'll be
Thank
happy.
you.
Yeah.
Okay, Janet has raised her hand. Janet, go ahead.
Yes, hi, thanks. Wonderful, wonderful talk. And I think between your two talks, both were very helpful. I got a sense that computer ontology lives between mathematical foundations and library science. And that both of those really illuminate what is going on here. I had a specific question about the five categories there. Which Indian tradition does that come from? The choice of the personality
It's
matter?
like Hindu philosophy, yes. Hindu philosophy has got Pancha Mahabhutas out. I mean, those who follow Hindu philosophy says everything is made out of 5 elements, including the human body.
Mm-hmm. So a number of the questions we have in inconsistent ontologies would come from people choosing different foundational elements there. So if the choice of those five could be treated in a topos, where you then would say, someone else chooses another set of foundational categories, then that would be very interesting. Thanks a lot.
Yeah. So it doesn't matter. I showed you the edges of a cube, the three-dimensional figure, where one edge was the topic of discourse, the other was time and space. So the topic could be modeled in how many ever categories that one envisages. And Ranganathan envisaged PME along the topic line. His own disciple envisaged 13 categories. And the disciple of the disciple then said, no, it all maps back to the 5 fundamental categories. So there are various theories around that.
Right. Very good.
Yeah, thank you.
Very good. Yes, that was a good insight, Janet. Are there any more questions? All right. Okay, there was a comment in the chat. Oh, wait, here's Eve. Could you unmute?
Oh, no, yes, thank you. Yes, a very interesting talk. Thank you very much. I think it's very interesting. The ISO 22274 is a standard about international classification systems. And the recommendation is to use an hybridation of enumerative classification and facet classifications. For the top level, for instance, classes to use an enumerative classification. And when you go into more detail to use a facet classification, which will be more efficient than an enumerative classification. What do you think about this hybridation of the two types of classification?
Sure. It's like I explained, there is through faceted classification, we are trying to address more complex problems of representation. So if you have that level of complexity, then you use faceted classification. You think, no, we don't need that. I only need to organize 100 books or 1,000 books at a very generic level. No, you don't need to use that. I think we should just make peace with, we can live with the enumeration. But enumeration by its, the very term, sees the limitation. You cannot enumerate the concepts in knowledge. You cannot. There is a biological growth to concept. So you should have the framework also that has a biological growth.
Yes, thank you. Yes, I think what Ranganathan said about the classification was, it was a kind of like he took the example of a family or a house where you can welcome the cousin or all the people. And I think, yes, it's a good metaphor of this, as you said, as the growing and the flexibility of the classifications is probably more adapted also to changing world, to always changing world, yes.
So the best example is like this year I have, say, 10,000 books in the library, and next year I'll get another 2,000 books added to that collection. We don't put those 2,000 at the end of the collection. We have to integrate them into the collection at their rightful place. So that's the kind of flexibility we need in the system.
Yes, thank you. Yes.
Yeah. Thank you.
Any other questions? Okay, well, in the chat, Michael DeBellis pointed out that Cantor never claimed that math is now consistent. And in fact, the later work of Gödel and Turing, of course, showed that consistency is not that easy to show, if you can show it at all. It may, in fact, be impossible to show. In my paper, Much Ado About Everything, and there's a link to it in the slides. I show the progression of ideas from Cantor to Gödel to Turing, how they actually use the same technique to show their results, and refer to each other. So indeed, what happened was that the inconsistency, the specific inconsistency that Gödel found, that Cantor found, was that the set of everything is not consistent. And it was that fact that kind of upset the theologians, who said, are you saying that God does not exist? Seriously, that was the issue. And Cantor himself communicated with the Pope to assure him that he was not claiming that at all. And as a result, at least for the theologians at the time, yeah, the issue was resolved. And it subsequently, mathematicians developed techniques that said, okay, we can deal with this and resolve that particular inconsistency. Which is not to say that we've now proved that mathematics or any other field is consistent, only that we now feel that we have a way of dealing with such problems. Would you say the same, Devika?
Yes, actually our Living Knowledge project was all about this, where we accepted that knowledge is diversified. It's never ever uniform, and we cannot be expected to be uniform. Point number one. Point number two was not to treat the diversity as a problem, but to treat it as an asset, because the diversity enriches knowledge. Okay, while we treat it as an asset, we wanted to find out again a very flexible framework which we could use for as a representation framework. So this is what we did in the Living Knowledge project, and I very much tend to agree with what you said.
So, okay, we've run a little over, but I think we had a really great session today. Thank you, Devika. That was a really excellent presentation.
Thank you so much.
And now, with that, I will now adjourn this session.